Working principle of PMMC, Permanent Magnet Moving Coil, Instrument PMMC, Permanent Magnet Moving Coil. Instruments are widely used for measuring electrical quantities such as current and voltage in DC circuits. The working principle of a PMMC instrument is based on the interaction between a magnetic field and a current-carrying conductor. Here's the step-by-step working principle. Permanent magnet. In PMMC instruments, a permanent magnet is used to create a strong, uniform magnetic field. The magnet is positioned in such a way that the magnetic field is perpendicular to the plane of the coil. Moving coil, a coil of wire, usually made of copper, is placed within the magnetic field. The coil is mounted on a spindle or axis, so it can rotate. The coil is designed to move when current flows through it. Current flow. When DC current flows through the moving coil, it generates a magnetic field around the coil due to the electromagnetic force, Lorentz force. This magnetic field interacts with the magnetic field of the permanent magnet. Torque generation. According to Fleming's left-hand rule, the interaction between the magnetic field of the coil and the permanent magnet produces a torque on the coil. This torque causes the coil to rotate. Deflection of the coil. The coil is mounted on a spindle, and it deflects when the torque is applied. The amount of deflection is directly proportional to the strength of the current flowing through the coil. Damping. To prevent oscillation of the coil and to provide a smooth reading, a damping mechanism, typically made from a metallic plate or a vane in a fluid, is provided. This prevents the coil from oscillating back and forth after reaching a position of equilibrium. Pointer and scale. The moving coil is connected to a pointer, which is mounted on a scale. As the coil moves, the pointer indicates the value of the current or voltage being measured on the calibrated scale. Restoring force, a spring, or a similar mechanism, is used to apply a restoring force that brings the coil back to its zero position when no current flows. This spring is also calibrated so that it balances the torque generated by the current. Applications of PMMC instruments. PMMC instruments are particularly suitable for measuring DC quantities. Some of their key applications include DC ammeter. When configured with an appropriate shunt resistor, PMMC instruments can be used to measure the DC current in a circuit. The deflection of the pointer is proportional to the amount of current flowing through the coil. DC voltmeter. PMMC instruments can also be used to measure DC voltage by placing a known resistance, usually in series with the coil, to limit the current. The deflection of the pointer is then proportional to the voltage applied across the coil. High precision measurements. PMMC instruments are known for their high accuracy and precision in measuring small electrical quantities. They are used in laboratory settings, research, and calibration. Panel meters. PMMC meters are widely used in various types of panel meters, such as in power supplies, battery chargers, and test equipment where accurate DC measurements are required. Portable meters. PMMC instruments are also used in portable handheld meters for maintenance and testing in industries like electronics, telecommunication, and electrical power systems. Advantages of PMMC instruments. 1. Accuracy. PMMC instruments are highly accurate in measuring DC quantities. 2. No parallax error. The pointer is directly visible on the scale, minimizing parallax errors. 3. High sensitivity. They can measure even small amounts of current or voltage. 4. Linear scale. The deflection of the pointer is linear with respect to the measured value, which simplifies reading and interpretation. Limitations of PMMC instruments. 1. DC only. PMMC instruments are only suitable for DC measurements. 1. They cannot be used for alternating current, AC, without modifications. 2. Limited range. The current or voltage that can be measured is limited by the size of the coil and the strength of the permanent magnet. 3. Delicate. PMMC instruments are relatively delicate and can be damaged by overloading or shock. In conclusion, the PMMC instrument is a highly accurate device for measuring DC electrical quantities, primarily due to the direct interaction between a current-carrying coil and a permanent magnetic field. Its simplicity and precision make it an essential tool in many electrical and electronic applications.